Hi, everybody. It's time to get started with our Altinity webinar entitled Tips and Tricks Every ClickHouse User Should Know. Before we dive into the webinar and get into the details of playing around with ClickHouse, I'd like to introduce you to a couple of key things about this webinar. There is a question and answer box that you should be able to access from the control panel. Feel free to pop in questions during the webinar. If it's something I can answer in passing, I'll do so. One of my colleagues, Mikhail Filimonov, will be joining me in just a little bit and will also be able to answer questions in the background. So feel free to queue them up and we'll try to get them answered. We'll also have time at the end of the webinar. We also have a poll which we're going to run at the end of the webinar to ask you how this webinar met your needs, and also to ask about topics you might like to see in the future. So if you'll stick around and help us fill that out, that will ensure that we can give you better webinars in future. I would also like to extend a special welcome to a number of Altinity customers as well as friends who are on this call. It's great to have you with us, and we hope you enjoy the webinar, as we hope everyone does. All right, just a quick introduction to the presenter. That's me. I'm Robert Hodges. I'm the Altinity CEO. I'm also a database geek. I've been working on databases since 1983. My first one was something called Model 204, a very popular pre-relational database back in the 80s. Worked on a number of other database types since then, and in fact, ClickHouse is database number 20 that I've worked on, although sometimes it's hard to keep count. Altinity is the leading software and services provider for ClickHouse. We are basically the company that makes ClickHouse safe for enterprises to use. We're major committers to the project number 2 after Yandex, do a lot of NRE, offer 24/7 support, offer POCs and training, and we're a community sponsor in the US and Western Europe. If you've attended any events recently in either of those areas where ClickHouse is present, you probably met some of us. Okay, that's it for introductions to us. I'd like to do a quick introduction to ClickHouse itself for those of you that are new. So ClickHouse is a SQL data warehouse. The way I like to explain it to people who have some experience with data is imagine that MySQL, which is a famous open source database, and Vertica, which is a pioneering data warehouse, got married and had a baby. That baby would be ClickHouse. So from both of them, of course, it understands SQL. That's its native language. From the MySQL side, we get open source. We get portability across any environment where Linux runs. We also get ease of management. From the Vertica side of the house, we get shared nothing architecture, column storage, extremely efficient parallel and vectorized execution, and the ability to scale to many, many petabytes spread across many nodes. So those are key considerations. And then, of course, ClickHouse itself brings to the table extraordinary speed. And if you've used ClickHouse, this is probably one of the first things that you notice about it. We actually had a webinar a couple months ago talking about how to make ClickHouse go even faster. Have a look on our website if you're interested in that topic. For now, what I'd like to do is dig into the tips. This is something that, based on a poll that we ran in some of the previous webinars, was a popular topic. And what I'd like to do here is show you just some of our favorite ways, little tricks that we use when we're working with ClickHouse to make applications easier to debug, run better, run faster, so on and so forth. There's 9 of them there today, and we'd be happy to take suggestions for future tips that you'd like to see explored in more detail. So one of my favorites is a really simple one, which is that ClickHouse has a very powerful server log, which some of you may have used. It is extremely helpful to look at the log and figure out what your query is doing. Excuse me. So one of the things that ClickHouse does is it has a feature that allows you to get the log messages sent directly back to your client so you can just look at them when you're running the query. This is much easier than figuring out where the ClickHouse server is, where you ran, and going and collecting the messages there. Let's see how to do that. So if you're using the ClickHouse client, which is a really, really great command line client for ClickHouse, there's a couple of good ways to do this. One of them is to just do a command line option called send logs level, and when you start ClickHouse client. The other thing is that you can do it interactively. And this is such a cool feature. I'm not going to do too many demos in this presentation today, but this one is so cool that it's worth viewing it. So let's have a quick look at how this works, and you can appreciate the power of this feature. So I'm going to go ahead and fire up my ClickHouse client. And what I'd like to do here is I'm going to go ahead and set the logs interactively. Let's, have some junk here. So I'm going to go ahead and set this property send logs level, set it to trace. And then if I do that, any query that I enter after this, I'm going to get log messages sent back. So if I just execute the most trivial query possible, which is select one, what will happen is in addition to getting the results, I also get all the messages that the server generated when it was processing this. Obviously for select one, that's a very small amount of data, but it is still significant because as your queries get larger and more complex, you have this stuff popping up right on the screen in front of you, and then you can debug your query, figure out how to make it perform better, so on and so forth. This is one of my favorite tools for figuring out what's going on inside a query. We can turn it on and off, so let's go ahead and set it back to none, which is the default setting. So I'll do that, and then if I run this query again, I just get the result back. This is an incredibly helpful feature. It's a really small detail, but a very thoughtful feature that makes it very easy to figure out what ClickHouse is up to. One of the interesting things is that it works not only inside the ClickHouse client, but actually within client libraries. So here's an example from Python. If you're a Python user, what you'll do, I'm showing the script here, you'll import logging. You'll go ahead and set the most basic configuration. Of course, you may have a more complex configuration, but what you're doing is you're enabling logging within Python. And then if you go ahead and execute a query, and in this case I'm using the ClickHouse driver, which is one that we recommend highly for Python clients, I'm going to go ahead and connect using this client object. I'm going to define a settings object, which is something that I can insert in my query, and I'm going to set the logs level to trace, and then I'm going to run my select one. And if I print the result, actually even before I print the result, you'll get a bunch of log messages which show everything that happened on the server. So you can do this not only in the ClickHouse client, but also in your applications as well. As you can see, you have to make code changes to enable it easily, but this is something to think about and include in your applications. As you go to other client libraries, you'll have to play around and figure out how to enable the libraries, but it works very well in Python. So that's tip number one. What I'd like to do is keep cranking along. And another tip that we commonly give people at the design time or when they're optimizing the performance of their applications is to use encodings to reduce data size. This has an enormous impact on performance. In fact, it's sometimes one of the simplest things you can do to get huge boosts in both ClickHouse performance as well as reduce the amount of storage or space that's taken up for storage. So let me jump in and show how this works. So ClickHouse has a couple of different, well, first of all, I should explain what an encoding is and how it's different from compression. As most people on this webinar probably know, ClickHouse by default compresses data. So the default compression, if you don't change anything, is LZ4. If you and so your data will compress, but compression knows nothing about the actual semantics of the data. What an encoding does is it's a transformation on your data that takes advantage of knowledge of the data type and how it's structured to reduce it to a more efficient form that will, in many cases, compress better or just so reduce the data size that there's much less to compress. And here's a couple examples. So a very common encoding that you can use is called low cardinality, and that can be applied to strings. And what it basically does is take your string values and turn them into a dictionary encoding. Let's take a simple example. Suppose you have a database that contains a bunch of airline data, and you have references to the airline or to the airport names. So there's only a fixed number of airports. There's a few thousand of them in the United States. So if you put low cardinality on that, it'll basically turn each of those into an integer value and store that in the table instead of the full airport name. So this reduces the amount of data to compress significantly. A couple other examples here are using the codec keyword. We're using delta and double delta. These are codecs that transform the data and take advantage of the fact that you may have a monotonic, or you may have an increasing value, in which case it's much smaller to store the deltas between succeeding values, or double delta where you're actually storing the slope. And particularly as for something that's monotonically increasing or otherwise has a nice even slope to it, you're going to reduce the data enormously. So we have this table which has these codecs, and what I'd like to show you is just some simple examples of the effects of this. So what we'll do is run an insert here where we're going to load data in. We use the system.numbers table. If you're not familiar with that, that's actually another good tip. It automatically generates a series of numbers starting from 1 up to whatever limit you set, and you can use it to generate test data quickly. That's one that I use constantly to generate. So this will plug a bunch of data in. Looks like we're going to get about 100 million rows, and let's have a look. We're now going to run another very handy query, which is from the system.columns table, and we can now compare how much data we have, what's the uncompressed size, that's the third column, what's the compressed size, and then the percentage of data that's left over after compression. So with this, we can see pretty easily that the double delta and the delta compression result in enormous reductions of data size. In fact, double delta with LZ4 compression in this particular case results in a data compression down to 0.1%. So that's a 1,000-fold reduction in data. The effect of low cardinality is a little bit more subtle. What happens is it reduces the data up front, turns it into integers, but those then don't compress particularly well. So the real compression rate is actually, you have to start with the uncompressed data size and then compare it with the final compressed data size. In this case, it reduces it by a factor of 90%. So it's also a big win, particularly for things where you have long strings. So those are sort of useful for reducing storage size. But another thing that's interesting is the encodings really help query speed. And here's an example that what we're going to do is we're going to just select off that column A, which is a string, and we're going to do a group by the string name. We run that query. So pretend we're just doing something with the airline data. We're grouping on the airline names. We run the query and it processes 100 million rows in about 0.7 seconds, so 0.7 of a second. If we do that same query on the column that was compressed or specially encoded using the low cardinality type, we get a much faster query. And the reason for this is the query can largely operate on integers, which are much smaller than the strings. So there's just less data flowing across the CPU as we're processing the query and doing I/O. So that in this particular case reduces the size or the wait time or the response for the query by a factor of at least 4. So encodings reducing, and with ClickHouse in general, reducing the amount of things that you have to read out of storage is almost always a win. for performance. It's one of the basic ways that we improve performance of queries. So there's a bunch of encodings. I've listed 5 of them here. Low cardinality, which we talked about. It's called low cardinality for a reason. It works best when you have less than 10,000 unique values. So that's something to bear in mind. Delta and double delta are good for, delta is good for time series where things are increasing and sort of regularly by small increments, say by a couple seconds with each measurement. Double delta is for increasing counters, particularly as they have, if they have a nice linear slope. Gorilla is nice for gauge data. It can be used for things like doubles and floats. And then T64 is one. I haven't used that one, but it can be used for integers other than random hashes, which vary randomly. The compression levels will vary depending on whether you use LZ4 or ZSDD. So we do recommend that you play around with that a little bit. In general, ZSDD is a bit more expensive, but it has better compression. LZ4 is the default and is what you get out of the box. You can experiment with these, see how it improves things. And that query that I showed you from system.columns gives you very precise information about what levels of compression you're achieving. So this is something that encodings are something that it's almost the first thing we look at when we help somebody design a schema, and it's definitely something that should be top of mind when you're designing your own tables or looking to improve their performance. Here's another great one. So we love materialized views, and materialized views are something that you should look at whenever you have a table that's not quite in the state that you want it to do a fast query. So in databases, one of the fundamental things that you learn is that the organization of data is everything. That is the fundamental thing that improves your performance. And a materialized view is a transformation on an existing table to create a new table that's organized in a way that is better for some queries. Let's take a concrete example, which is finding a last point. So this is a very common time series problem. And what I'd like to do is show you an example. Let's imagine that you have thousands of VMs running out in a public cloud somewhere, and you're taking constant measurements of for monitoring on these VMs. And in this particular case, we're taking measurements of CPU utilization. And let's say that every few seconds we're going to go out, we're going to look at the CPU utilization, and we're going to ask, and so we'll have this time series, which gives us a nice historical record. Excuse me. But the question we want to answer here is, what's the current CPU utilization for each host? And what that means is we're going to need to actually go into the time series and find the last entry for each host. This is something that you can do in a ClickHouse query, but it's actually relatively inefficient because we're going to have to go ahead and read all of the data to find the max value and then for each CPU, and then aggregate that together and present the results. There's a better way. So what we can do is, I'm going to skip over what you could do and just go straight to the solution, which is to create a materialized view. So the basic idea here is we're going to create a view which is just going to contain the data for the last measurement. And the way that a materialized view works is it's like, if you haven't used them before, they're like triggers. When anything enters into the base CPU table, it's actually going to invoke this view and run the query on the part that you're inserting. And what we're going to do in this query is do kind of a trick where, first of all, we're going to look for the maximum state of this value called created at. That's the time when we took the measurement. And then what we're going to do is, in these argMaxStates, we're going to look for the matching values of the created date and the time as well as usage idle, because we're trying to figure out what the utilization is. The value we're most interested in is what was the idle usage on the CPU at that time. So what this does is it finds the max value of the time of the measurement, so the latest time measurement, and then selects the matching values off that row for created date, time, and usage idle. So what this does is it basically reduces a whole stream of data down to the last point by CPU. And we're grouping by tags ID. That's actually the name. That's actually a tag that identifies the CPU. So the query, if you haven't worked with these before, the syntax seems a little bit foreign at first, but you'll quickly adapt to it, and it becomes easier because you'll see how much it improves the speed. So when we're reading these out, there's a trick with materialized views that they store what are called partial aggregates. So when we select them out, we have to use what are called merge functions to force ClickHouse to go ahead and take the partial aggregates, glom them together, and get the final number for each of our CPUs. That's what these argMaxMerge things do. And so this is just and what we're doing here is to make things simple for people. We're just sticking it in a view that does this roll up automatically. And then what we have is, for the person who's running it, they actually run a very simple query and selecting from that covering view, and then they get a very fast query result. In this particular case, I didn't show this slide, but the query that we were running on the test data took on the order of a second. It's reduced down to 5 milliseconds. So a 200-fold increase. Actually, as your data increases, the effect of doing this is enormous. And one of the reasons why it's so efficient is we reduced from 100 million rows down to 14,000 rows. So the amount of rows we had to read becomes vanishingly small, and that means that this is super efficient. So materialized views solve a lot of problems, and they're one of the most powerful features in ClickHouse. Whenever as I said at the beginning of this tip, whenever you're looking at something and you feel that you've optimized the data in place as much as you can, you need it to be sorted a different way, you need it to be aggregated a different way, something that deviates and is incompatible with the base table. A materialized view is almost always the right solution. Excuse me. Let's look for another great trick. As we're reading time series data, it's very common to have a bunch of different time series that are being read in from different types of options. Oh, got a question here. Let me just go take this right now. How long does it take to build a materialized view? That's a great question. That particular materialized view that I built probably took on the order of 30 seconds to build. It's actually very small in relation to the data. So building a view, so for example, it depends on what your view is doing and how complex the query is. The view is going to be, if you're building it from scratch on existing data, it's going to scale linearly, of course, with the number of rows that you're processing, but the time is small. So for example, I have created views on a billion row table. It can take like a minute or so to populate the view. What this also means, and this is a really important thing about materialized views, is once they're set up, they populate automatically as you insert data. So the cost of actually populating the views is relatively small. You do pay it at insert time, because what will happen is the view will get triggered. You'll put the stuff into the view, and then you'll finally add your data and return to the client. So there is some delay introduced, but as long as the views are not excessively complex, it's not that much. And the question, does it update and refresh in real time? Absolutely. This is a really important point. As you insert the data, the view is populated automatically, and any aggregates you have are immediately are immediately available to you. And I think compared to other databases I've worked with, this is one of the really powerful features of ClickHouse. Okay, let's go ahead. Oh, 1 second, I made a small mistake here. Just 1 second. So, sorry, having a little bit of a problem with promoting panelists. By the way, my colleague Mikhail Filimonov has joined us. He'll be in the background and able to answer questions. Okay, so coming back to time series, you have a bunch of time series coming in, and maybe you don't know the properties that are going to be in the time series. Like sometimes you're interested in, if it were a time series related to cars, you might be interested in color, number of doors, the amount of gas in the tank, performance, various performance metrics from the engine. If it were some other kind of device like a tractor, you might be interested in something different. Just picking that as an example. That's not very compatible with a table, but fortunately, ClickHouse has a great solution to this problem. So here's your tabular data, and obviously this type of information, and we're using CPUs as an example, is not going to be compatible with having stuff that varies with each measurement. So we can go from that, and instead of having a table where things like the usage for user, usage for system are all done as separate things, we can now create a table which has a pair of arrays. And this is the common way to solve this problem. So we'll have a set of metrics that we're collecting on CPUs that could vary depending on what the CPU type is. For example, ARM versus Intel versus AMD. And so we'll have the metrics names, and then we'll have matching values in an array of floats. And what this now does is it allows us, it doesn't matter what comes in, we'll basically be able to read it. So here's an example of where we insert values from JSON. So what I'm showing here is JSON one row format. And we have the metrics name, so we've lined things up in the JSON so that it matches the schema we're loading. But you can see you have the usage for the user, system, idle, and the nice are all sort of corresponding values. And each row can have a different set of values because these are just values in arrays. So this gets the data in. And if we just had arrays, that wouldn't be so interesting. We can have different key value pairs, but what's really cool about ClickHouse is it also gives us some ways to pivot these arrays so that we can turn them back into nice rows again. So for example, what we can do here is we can pivot this back at will to turn it into a fully tabular form. So we've got it stored fairly efficiently in the arrays. And what we can now do is use something called an array join. And this is a really interesting feature that I have not seen in other database types. But basically what it does is here we're selecting from that table I created, and we're going to select the name and the value of each metric that we've taken. But we're going to use this array join, which is going to pivot around metrics name and metrics value. So it basically blows these arrays out, and for each entry in these paired arrays, we get a row. So you can think of it as kind of which is then joined with the data in the rest of the row. And if you look down, you'll see exactly that. You'll see exactly that information. Here's the first 4 rows come from the first measurement with its 4 array values. The next rows come from the next measurement, so on and so forth. So this is a really powerful feature. And in fact, array joins allow you to do all kinds of, sort of interesting pivots and then reconstituting of data. It's one of the most powerful features in ClickHouse. It does bring up an issue, though. So you've got this data in arrays, and that's great, but it's kind of, you'll have to go, if you're fishing things out regularly. For example, just about every CPU will in fact have the same timing values. So we can keep them in the array. That's great, but wouldn't it be nice if we could have them actually appear as a column as well? That would be easier and actually faster to select off if some subset of these things could be easily converted to columns. And we can do exactly that with what are called materialized columns. So here we have that same example, and what we're going to do is we're going to alter the table, and we're going to add a column called usage user, and what we're doing is dipping into the arrays, and we're going to fish out the value of the metric called usage user. And this basically turns it into a column. When you run this command, it just changes table metadata. So if you already have a bunch of data loaded, it actually makes no difference to the organization of the data. And what will happen is when we run the query over the old data, ClickHouse will just recognize that value doesn't exist in the table, and it will compute it automatically using the formula that we just gave in the materialized column creation statement. But when you add new data, what will happen is ClickHouse will automatically apply this formula and create a real column with that data. So over time, you're going to be much more efficient as you're working on this data. So this is a great way. You can start without knowing what your schema is, and then over time, as you learn more about the schema, or you decide that some columns are used so commonly that you'd like to optimize them, because of course, once you put them in storage, then they're able to be, optimized using things like codecs and things like that. So you can go ahead and change them at need. This is a really great feature. And it's really simple. So our next tip is to use dictionaries instead of joins for dimensions. Let's talk a little bit about dimensions, because this is a big part of data warehouses. It's very common to have star schemas in data warehouse. And actually, one tip we can talk about with ClickHouse is that in ClickHouse, actually, star schemas are somewhat less common than in other implementations. And the reason for that is that repeated data, as we saw, for example, with when we were talking about codecs, compresses very, very well. So you can actually denormalize your fact table. So you have the central table of measurements. This can be denormalized quite substantially because it's actually a relatively low cost in many cases to add in columns. That's because if you don't query on the column, you never read it. So there's no I/O cost for running a select on a column you don't touch. And the storage cost can be quite minimal because denormalized values tend to repeat a lot, especially if you're clever and make sure you're sorting data in a way that kind of follows the way that the dimensions are built. So those are two reasons why you might want to denormalize and actually not have a lot of dimension tables. But at some point, you're going to need to have them. So here's an example where we have the CPU table, and then we have the org that owns it, budget data, the tags, which are the names of the computer, the actual computers themselves, and then projects, which are using those VMs. So this is your star schema. Now, what can happen in ClickHouse is that a couple things. One, these dimension values are often mutable. So, for example, a project may change its name, and you don't really want to do a query where you give the original name of the project. That just doesn't make sense. So that's an issue. The other thing is that you need a join for every dimension. And ClickHouse, as I think most people on this call are aware, does right and left joins, but you end up having to do a bunch of subqueries, and the joins can sometimes be fairly painful and result in lower performance if you have to do a lot of them. So as a result, what we'd like to do is keep these things in separate tables and not have joins. And this is something that dictionaries solve. So a dictionary is an alternative to a join, where basically we take the contents of the table and we pull it into memory, and it's just already there and ready to be used. We don't have to read it. It's basically cached in a hash table. The traditional way to, we might say the legacy way to define joins is shown here. This is where you stick a dictionary definition. You have a bunch of XML tags that define where it's coming from. And in fact, in this case, I'm reading from a MySQL table, and we're sort of telling it how to find it, and then we're also giving some information about the structure of the dictionary as well. A good tip, which we don't show here, but is now possible, is in recent versions of ClickHouse, you can actually use DDL to make the dictionaries, which is much more attractive. And the next time I do this talk, I'll have an example of that. But this defines the dictionary, so and the first time you touch it, it's going to, by default, will suck the data into memory, and then it's available for joins. We have some special functions that we use to avoid it. The syntax is a little bit interesting, but basically what this does is we say we have this dict get string that gets a string value, and basically what we do is give the name of the dictionary, which is the hash table, and then sort of what's the key value that we use to do the lookup. So that basically allows us to get these values. So and then we can this gives us the value of in this case the usage without having to do a join. So that's a common enough way to do this. And one thing that's actually pretty important here is, if you were looking carefully at the XML, you'll see that I actually had it stored in MySQL, and that's a very common pattern with dictionaries, because these dictionaries are mutable. So you can put them in ClickHouse, of course, but you'll end up then having to do mutations on them, maintain them. Sometimes it's just easier to go stick them in a database like MySQL or Postgres, where you can easily update them, and then ClickHouse is perfectly happy to fetch the dictionaries out of those locations. So this is a very common pattern for how to build, how to build systems that have large fact tables with mutable dimensions. In fact, it brings up another issue, which is maybe you don't want to use dictionaries. So if you don't like dictionaries, well, this next tip is for you. You can use something called the MySQL database engine. So the MySQL integration, the ClickHouse MySQL integration is particularly good. There's a bunch of different ways that we can fetch data out of MySQL. Dictionary is one. They also work with Postgres. But MySQL also has what's called the MySQL database engine. And this is so cool, I'm going to do a demo of it. Let me just show you quickly. Here's an example. In ClickHouse, we can create a database which refers to a MySQL database. And we can that then materializes as a database inside ClickHouse, and we can go in and we can do any operation on the tables as if they were local to ClickHouse itself. And I like this feature so much that I'm just going to do a quick demo of it. So let's go ahead, and we're going to show databases. So we have something called MySQL REPL. And let's do a show create database and see how it was created. And it was actually created using exactly the command I just used in that example. And if we use that, so we can use it as a database. So we'll go into it, and we'll do a show tables. There it is. So it's got 4 tables. Where are these tables coming from? Well, they're coming from MySQL. Let's go look at them in MySQL, and we'll show you how convenient this is. So do a show database here. Oops. Have to remember that we have to do a semicolon. The database name here is called REPL, so we're going to use REPL, and we'll do a show tables. Let's just show how convenient this is for update. I'm going to make a new table. Here it is, create table foo. Go ahead and do a show tables here in MySQL. Sure enough, we see foo. Go over here and do show tables. Voila, it appears on ClickHouse. And any value that you that you enter into that table will, of course, also be immediately accessible. Let's just show an example. In fact, you can run queries on MySQL, fully on MySQL data from ClickHouse. I've got an example posted here back in the, I'll have to walk back a little bit to get to the, here we go. This is just an example of a query which is getting some data out of this test data set. But it's a somewhat non-trivial query with a nice inner join, and the ClickHouse implementation is reasonably efficient. So, for example, if there are filters that can be pushed down, they will get pushed down into MySQL. So, paradoxically, you can sometimes get better performance on MySQL by running the query from ClickHouse than you can in MySQL itself, and that's because ClickHouse is very good at parallelizing operations. So this is a great feature, one that I really always get a kick out of using. So let's go back and get back to our presentation. And we just got a couple more tips here. So there we go. There's an example of the query and the predicate. That predicate was actually pushed down into MySQL, so we didn't bother to bring everything back from that table. We actually pushed that where filter down into the applicable table in MySQL. The way you can prove that is turn on the MySQL query log, and you can see exactly what's coming from ClickHouse. TTLs, really interesting feature. Every now and then, it's very common in time series data that, or actually data in general, that you will keep data for a period of time and then you'll delete it. So ClickHouse, as you probably know, is not optimized for deletes. In fact, data warehouses in general are the way that they get very, very high, for example, ingest rates, the way that they get very efficient query performance is they don't bother to, they try to avoid making things mutable because that slows things down. You have to do a lot of table maintenance. So here's an example of a table that tracks traffic for a website. And if we want to drop data from this table, traditionally we had a couple of options inside ClickHouse. So this is partitioned by month and ordered by customer ID and date, but it's the partitions that are significant. So the first thing you could do is you could just go and drop a partition. And this is extremely fast. It's as quickly as we can unlink the inodes on the file system, the partition is gone. But you can't do part of a partition. Now, if you want to delete specific data, you can do an alter table delete, and with this filter. And what will happen is that will go into the background, and then ClickHouse will, over time, and depending on how much you're changing it may be more or less, it will go ahead and delete the data. You'll have to wait until the mutations are processed, and then the deletes are done. There's now a much better option, which is called a TTL. So the idea with the TTL is that you're going to excuse me, add this this clause to your table creation, and in this case, what we're going to do is we have a date time added to the traffic table that gives the date when this was created, and what this TTL says, delete it when the time is at 90 days plus the date when this was created. So basically, this data will disappear after 90 days. Now, it's not quite 90 days because ClickHouse is not constantly looking for expired TTLs. There is a setting merged with TTL timeout that affects how commonly it does this, but you generally want to set this to be on the order of, it defaults to something on the order of about a day. Mikhail, I'm sure, can give the exact setting there. But this is a very powerful feature. So it also is interesting because you can use it more flexibly than what we see right now. Just a moment. Pardon me, I have a little bit of a cold. So we have so what we can do is, in this case, we can actually put the retention inside the table, because any retention that comes back with a time is going to work. Excuse me. And the only requirement is that the value must be based on the data in the row. So you can use this, for example, to put a variable retention into the table, and then you can peel out the rows based on that value. We've seen people do this. For example, in multi-tenant systems, they'll have varying preservation dates depending on the quality of service they're offering to the tenant. One final thing that I want to mention is that TTLs are going to undergo a really substantial expansion in the next couple of months. And this is a feature that we're working on right now. The PR should be merged probably in the next 30 days or so. Probably see this stabilize and be fully, excuse me, and be fully available over the next couple of months. But we've been doing a lot of work to implement what is called multi-volume storage. And if you read our blog, you've seen a couple of recent articles that were published based on work from Mikhail. And in what we're implementing now is an extension to TTLs that allows you not only to delete but also to move data across different storage types. So you will be able to create a table like what we showed in the example, and for example, you'd be able to have your data initially put on one quality of storage, in this case SSD. After 7 days, it will move to HDD. And then, actually, this is, I think I got this example slightly, we can actually have another level, but this will basically, what this is basically doing is controlling the movement across these different volumes at different TTLs. So this is going to be extended not just to delete data, but also in turn allow you to move the data across storage with different QoS or any property that you want. It doesn't really matter to us. So this is a very interesting and innovative expansion of TTL uses. So stay tuned. You'll see more information on this early next year. Final tip, we're approaching the end here, and that's to use replication instead of backups. So backups are still sort of a shaky topic on ClickHouse. That's something we're working on, but having a nice solution that is as simple to use as something like pgdump is still, which is the Postgres dump utility, is still something that's not quite there. For anything larger than a small cluster, we actually recommend that people use replication instead of backups, because the amount of storage of stuff that you're going to need to store is so enormous anyway that using backups to protect yourself from data loss is not practical. So replication, if you're not familiar with it, works on a per table basis in ClickHouse. It's batteries included. So what happens is when it's set up, if you insert a part, which is like a block insert into a table called events, it will automatically get replicated across any nodes which are defined as replicas. And then ClickHouse is pretty smart about doing merges. So for example, it knows that you have the same parts available on different nodes. When it comes time to do a background merge, one of the nodes will take charge and say, okay, y'all are going to move, these two parts that we have, you're going to merge them into a single part, and everybody will do this in lockstep. This whole process, if you're a distributed systems person, you would recognize this requires consensus across nodes. We use Zookeeper to do that. So Zookeeper keeps track of what is the data that's being shared in that's being replicated. So what is the data we're managing? And it also helps us with leader elections, so that for things like merges, one of the nodes for each replica, for each set of replicas, will take charge and determine the order of operations for things that each node has to execute independently. So this does require us to set up Zookeeper, which we do here. Once it's set up, it's generally pretty reliable. And there are some other things that you need to do. Of course, you'll need to define the sharding and replication layouts. Those are done through XML files. So there's a remote servers tag, which actually, if you go in and look at the existing config.xml, you'll see this there. You'll basically have to define. It's up to you how these replicas are organized across nodes. It's entirely your choice. You can split them into shards with replicas, but within shards, you can have as many shards as you want. You can also then have as many replicas. Moreover, you can have multiple sharding and replication layouts. So you may have some tables that you just want replicated to every node. That's a performance optimization that then allows you to do local joins. So it's very flexible. But you basically set this up, and this allows you to now automatically have things replicated across nodes. We use macros, which are a ClickHouse feature that allows you to have consistent DDL statements. These are per server. So, for example, we have one where the default cluster value of cluster is going to be replicated. We're shard 1, replica 1, and then we can, we have Zookeeper tags. That's a final bit of setup. So this is all just sort of vanilla setup that you have to do. It may seem foreign at first, but it's fairly easy to do once you've got it all set up. And then finally, you can create tables. So once you have this stuff set up, you can go ahead, create tables, and these things in squiggly brackets, these are our macros. And this is an important, the macros are important because it allows us to execute DDL across the entire cluster. This is a create table on cluster command, and what that means is ClickHouse will see this, and then it'll go and replicate and execute it on every node on the cluster. So that sets up our replicated tables. So with that, I see a great question which I want to attack. This is the end of our tips. There should have been 9. That was what I got when I counted. Just very quickly, well, first of all, thank you for attending. I want to give you a special offer if you're new users and you'd like to find out more about how you can optimize your ClickHouse cluster, or you have specific problems. Give us a yell. We're happy to do a 1-hour free consultation and talk through whatever questions you have about ClickHouse and help you set it up as efficiently as possible. So that's something that you can check in with us at any time. At this point, I'd like to go ahead and kick off our poll. I promised early on that we would have that. Let's go ahead and launch that. So if you don't mind filling this out, we'd really appreciate it. It helps us make these webinars better. And then we'll go to questions. So I know that Misha has been answering questions as we went along. Thank you very much, Misha. Here's a great one. Can you use TTL to move data across nodes? Excuse me. The answer to that is currently no. But I'd like to expand on like how that might change. One of the really top, sort of top feature requests in ClickHouse right now is the ability to do automatic rebalancing. And so we are looking at ways that we could move data across nodes, but it's more designed. It's not so much thinking in terms of TTL. We have been thinking so far of using this as a way of allowing people to add nodes to the system and then either automatically, so basically automatically moving parts to, to new nodes. So let's say, for example, you have 5 shards in your cluster. You add a 6th shard. If you're familiar with how things like Cassandra work, you would expect the data to just migrate naturally across shards. ClickHouse doesn't do that. it's up to you to move the data. So that's why we're thinking about moving data across nodes. We have not thought about using TTLs for that, unless Misha has Michael has an example. If you have a specific use case where you think that would be relevant, definitely feel free to contact us. We'd be very interested in talking about that. With that, I think we'll stick around for a little bit longer. If there are any further questions, we'd be happy to answer them. Let's see. For tables with MySQL Engine, does ClickHouse actually copy the data or queries MySQL every time a ClickHouse query is fired? We query MySQL. One thing that can be added, though, is this is actually one of the simplest ways to migrate data out of MySQL into ClickHouse. If you have a big table and you'd like to pull it out, set up the MySQL, the MySQL database engine, and then just select it into a native ClickHouse table. So it doesn't cache it naturally. Michael, data encryption. So we don't.
Yeah, actually,
yeah, go ahead. This is one where you may have some thoughts on it.
Yeah, in general with big data, it is like ClickHouse is optimized for performance, and as you can imagine what encryption can make what performance worse. So it doesn't have any like native built-in options for encryption data currently, but you can use encrypted file system, and it should just work. Also, we know that some of our customers use encryption on cloud providers. So for example, if you use AWS, you can use encrypted disks on their site. ClickHouse itself doesn't currently provide encryption for on-disk data.
In communication between nodes, SSL, TLS, yes. The one exception to this is we don't have TLS encryption for the communication with Zookeeper. At least not to my knowledge. That is a feature which I believe is an issue. So we're looking at that. But generally speaking, anytime we're moving data, it can be encrypted with TLS, and I believe it's TLS 1.2, so it's pretty up to date. I've actually played around with that quite a bit, and the protection is quite good. We have a problem. Okay, here's one. Michael, if you see this one, I have problems with materialized views. It doesn't copy all the data all the time. I want to have
and it's actually it will work on distributed table, but it is like bad practice because it will work only if you insert through and do inserts through distributed table, and if you're on cluster, sorry, in that case your insert can go through any of node actually. In that case, it means that materialized view should also be distributed and should exist also on all the nodes. Actually, best practice is just always to attach materialized view to merge tree family table.
Yep, and then put a distributed table on top if you want to
see
everything. Yeah, LDAP integration, not there yet, but it's on the way. There is actually, Misha, is there a PR yet for LDAP? I know there.
I think it is. I think it is already there. It is like at what point it is not moving too fast, but it is as far as I know it really it should be done really soon. It should be finished.
Yeah, there's stay tuned on that. In 2020, we anticipate there's going to be major improvements in the authentication integration, so IDP integration, for example. We're working on that right now. We'll have more to say about that in early 2020. Great. We're actually at top of the hour. I would like to thank everybody for coming and joining us for this webinar. We really hope that it's been useful. We'll look very carefully at your feedback. Looks like we have some great suggestions for future webinars, don't hesitate to contact us on that. If you think of questions or webinar topics later, we want to present things that are most useful to the community. So with that, thank you very much, everybody, for attending. Mikhail, thank you so much for jumping in and answering questions and providing your expertise. And we'd like to wish you all a great day. Thanks, and see you soon.